You are listening to the Hydrac Podcast. In each episode, we share our knowledge with you in topics related to hydraulics and automation and control, from the basics to the current trends. Stay tuned. Hello everyone, welcome to this episode of Hydrac Podcast. I'm your host, William Shaw, and on this episode we are going to talk about the Australian regulations for pressure vessels and in particular hydro-pneumatic accumulators. And here in our studio, I have Mr. Ali Nejat. Ali is a mechanical engineer with over 15 years of experience in the fluid power industry. He's also a certified pressure vessel inspector, and he works for Hydrac as a National Development Manager for Industrial Hydraulics. So Ali, welcome. Firstly, what is a pressure vessel, and how do I know if I have a pressure vessel?
Thanks for having me, William. It's a very interesting subject and certainly an area that I've put in a lot of work over the course of past few years. We get that question all the time, that if I've got a particular vessel in hand, would that be categorized as a pressure vessel or not? There are quite a number of different standards and definitions defining whether a particular vessel is categorized as a pressure vessel or not. From the standard perspective, first and foremost, let's have a look at AS/NZS 1200, which is standard for pressure vessels. We get down to that in a few minutes and what that standard entails. But the definition of a pressure vessel in that standard is a vessel subject to either internal or external pressure, and it includes all the interconnected parts and components, valves, gauges, and other fittings, all the way up to the first point of connection to the connecting piping. But this is quite a broad terminology, and it doesn't really tell us if you've got a pressure vessel or if you've got a vessel subject to a bar, like 1 bar or 2 bar pressure, as opposed to a vessel which is subject to 400 bar pressure. What are the differences between the two? Are we going to treat both of them as the same type of pressure vessel or not? So, moving on, one of the most important standards in Australia, which is a design code for pressure vessels, by the name of AS 1210, it provides you with some visual/numerical methods of defining whether a particular vessel is a pressure vessel or not. So this visual method is pretty much a format of a graph. On the x-axis, you've got the inside diameter of the vessel, and on the y-axis, you've got the internal pressure that the vessel is subject to. And there is a curve in that graph. If you're falling below that curve, your vessel is categorized as a pressure vessel. If you are anywhere above that curve, that vessel is then considered to be a pressure vessel. But ultimately, it will come down to how hazardous that particular vessel is, and there are other methods of calculating the hazard level of the vessel itself as well.
So what are some of the regulations and legislation surrounding that, and also the hazard level you've spoken about? How do I determine that as well?
Yeah, very good question. Again, the rules and regulations pertaining pressure vessels, they all fall under the Work Health and Safety Act. Now, that also then divides into two different groups of regulations and standards. So in terms of regulations, we're looking at work health safety regulations, and in terms of standards, we're looking at all the approved codes of practices and standards that are applicable to the pressure vessels. Now, obviously the work health and safety regulations, you can find them online on the WorkSafe or WorkCover websites, and read through it, on the sections that are particularly focused on the pressure vessels, and learn more about what are the governing rules. But in terms of standards, there is an array of different standards covering or governing the pressure vessels and what we have to do with them. First and foremost, again, AS/NZS 1200 is probably one of the most important ones. That standard sets out some basic requirements and good practice for design, material, manufacture, examinations, testing, installation, conformity assessment, and all sorts of different other things that are applicable to a pressure vessel. Another very important standard that we are looking at is AS1210. AS1210 is a design code of a pressure vessel that sets out the requirements for welding, for pressure testing, the material. So if I, as a designer, want to design a pressure vessel, I grab the 1210 and I start looking at, all right, I have to choose the material from this particular standard. Then the thickness calculation is there, and the safety factors, and all sorts of different design-related subjects are included in AS1210. Then you've got a very important standard, which was, again, your question about hazard level. That's AS4343. That sets out the guidelines for calculating the hazard level of a pressure vessel. It suggests some numerical methods as to how we can calculate the hazard level. You know, it factors in parameters such as pressure. When we talk about pressure, we always talk about design pressure, not the operating pressure. So very important. Sometimes people come to us and say, hey, I've got a vessel, I'm just using it at a very, very low pressure application, you know. Whereas a design pressure might be like 400 bar, but I'm just putting 2 bar pressure in this accumulator, right? Am I obligated to go through all those, you know, regulatory compliance points? Certainly, yes. You know, we never talk about the operating parameters. We always talk about the design parameters of a particular vessel, you know. So another one is a design temperature. When we calculate the hazard level, the volume of the vessel is quite important for us. You know, how much pressurized fluid or substance it contains. The area in which the vessel is located is quite important. If it's, I don't know, if the pressure vessel is located in what the standard refers to as a major hazard facility, which is typically your refineries, and you know, if there's some sort of a damage to the pressure vessel, if there's an explosion or something, it will have a ripple effect on other parts of that plant. Or sometimes, you know, the pressure vessel is buried in the ground, right? Is that as dangerous as the pressure vessel which is in a refinery? Probably not, right? And also, AS4343 talks about the different substances that you can put inside a pressure vessel. A pressure vessel which is subject to pressurized water is probably not as hazardous as a pressure vessel which is subject to some corrosive, potentially lethal substance in there, right? So that's AS4343. It just gives you a numerical method as to how we can calculate the hazard level of a pressure vessel. Other standards are, again, another very important one is AS3788, which is the pressure vessel inspection code. We'll talk about that in probably another episode of the podcast, because that for itself is quite an extensive subject, and there's a lot to talk about when it comes to inspection of the vessels. There are the standards like AS3920, which is the quality assurance around the pressure vessel manufacturing. Who can actually design a pressure vessel? Who can possibly manufacture a pressure vessel? You know, AS3920 pretty much defines all of that.
So just coming back to your previous point on the design registration. So does my pressure vessel need to be design registered, and what are some of the steps required for that process?
Yeah, well, so it is one of those, this subject is quite an important one, and as the awareness around the pressure vessel increases in the market, we get that all the time. Obviously from Hydac's perspective, all the pressure vessels that we supply to the market are already design registered, so the clients don't really need to worry about that aspect of the work. But let's talk about a particular pressure vessel which doesn't have any compliance in place, and look at it from more a ground up. What are we going to do about it? So it all comes down to the hazard level, and that's quite an important factor in whether or not we need to do the design registration on a particular pressure vessel, right? So there is a national OH&S standard by the name of NOSH 1010. In its Schedule 1, it stipulates that if you've got a particular pressure vessel of a higher hazard level nature, typically hazard level is categorized as A, B, C, D, E. There are 5 different categories of hazard levels that we get. If a pressure vessel is of hazard level A, B, C, D, then by law we have to register the design of the pressure vessel and hard stamp all those design registration information on the particular vessel. Did I answer your question, or I think there was a second part to your question as well?
Yes. So, what are some of the steps required?
Oh, yeah, that's a good one. So typically we do the design registration process prior to manufacture of the vessel, right? Because first and foremost, we want to make sure that the vessel that we've designed is in fact compliant with the requirement of that particular code that we've chosen as the design code of the pressure vessel, right? So in Australia, again, we use AS1210 as a design code for pressure vessels. So let's say I'm going to do a design registration against AS1210, right? So as a designer, first thing that I will have to do is grabbing the code and just making sure that the pressure vessel, again, its material, its thickness, its diameter, its safety devices, whatever is associated with that pressure vessel is designed in accordance with AS1210, right? So after that, what we're going to have to do is, obviously, my design reflects on an engineering drawing. On that engineering drawing, then I will have to set out my basis of calculations. So I'll probably typically write down, the design code of this vessel is AS1210, the hazard level is such and such, the design pressure is this much, the design temperature is that, the volume is this, and all sorts of different related design parameters pertaining to a pressure vessel.
And all of these are stamped on the accumulator?
Eventually they will be, yeah. Eventually they will be, after I got my design registration. So then I've got a drawing of a particular vessel, which has all that information on it. Now, if I'm a certified quality company, which HYDAC is in this case, right? AS3920 gives us the permission to do the design verification, which is an essential part of that design registration process. AS3920 allows you to do the design verification internally for pressure vessels with a hazard level C and D, right? But for anything higher than that, which becomes hazard levels A and B, then you'll have to engage a third-party independent design verifier to do a design verification. So what the design verifier does is they grab the code, the design code, in this case AS1210, and they get your calculations and drawings, and they cross-reference the two. They make sure that you've done a good job in actually designing that vessel in accordance with that standard, right? And ultimately, if you've done a good job, hopefully, then they'll give you a certificate of conformance, or we call it verification or design verification certificate. So then you are a designer, you've designed a vessel to a design code, great job. A third-party verifier has verified your work, right, and has given you a certification that yes, in fact, this vessel is compliant with the requirement of the standard. Then the drawing and verification certificate will have to be sent to a regulatory authority for obtaining a design registration certificate. That's regulatory authority in Australia are organizations like WorkSafe, WorkCover. So we send all those documents to WorkSafe. Someone at that level will cross-check. They're not really doing more. They do some engineering work, engineering review, but really their primary task is just making sure that there is a person responsible for a design in Australia, there is a person responsible for verification of a design in Australia, and ultimately, if all documents are in a row, they give you a certificate of conformance, or in this case, we call it a design registration certificate. The design registration certificate has a registration number on it, right? It's just a unique reference number, which we call a registration number. So all those parameters that we were talking about, design pressure, design temperature, and everything, together with the registration number, then is hard stamped on the body of the pressure vessel. And once that vessel, and then from there, we can go ahead and manufacture the vessel, stamp all those information on it, and once the customer receives the pressure vessel, they've got a fully compliant pressure vessel in hand.
Thank you very much. So leading on to my next question, once I purchase an accumulator from Hydac, for example, all this information is stamped on the shell. Is there any more registration that I would potentially need to do? For example, a site registration or any other registration for the plant that I would need to do with this accumulator that I've purchased?
Certainly, yes. It's from there, once you've got a compliant design, it's like, buying a car. You just can't drive it on road. You have to go and get a registration plate, right? For pressure vessels, it's no different. You have to register your pressure vessel as an item of a plant. In some states, there are some exemptions. For example, Victoria, I believe, a couple of years ago, or maybe even further back, they said, right, no, the item of a plant registration is no longer required. But around Australia, as far as I know, in other states, the registration of an item of a plant is required. So typically, and that's very much the owner's responsibility. So the owner of the plant, or the owner of a pressure vessel in this case, they have to obtain all the documentation. Things like manufacturer's data report, design registration letter and everything. They present that through to the online portals available on the WorkSafe website, etc., and get that item of the plant or pressure vessel registered as an item of the plant. So there is full traceability. Everyone knows where that particular vessel has landed and the exact location of it, the identification number and everything regarding that particular pressure vessel. Yeah.
So for the owner as well, are there any further responsibilities once it's been registered to the plant?
Absolutely. All the responsibility actually lies with the owners, but the suppliers of pressure vessels, some of them, they oblige themselves, like, for example, Hydac, we ensure that all the pressure vessels that we supply to the market, they come with all those regulatory documentation requirements and everything. But once it's handed over to the owner, now when you want to put that pressure vessel in operation, the actual work starts, because now you've got a live vessel which is in fact subject to pressure, right? So you have to make sure that, first of all, you know exactly where it is, the item of a plant registration is done. Someone has done the commissioning inspection. There are routine inspections that will have to take place further down the track, and the responsibility very much lies with the owner to make sure that the vessel is not imposing any risk onto people's life, property, and the whole thing is intact. If an inspector rocks up to that plant and say, show me all those documentation that you've got available, they have to have a proper documentation archiving process in place regarding the pressure vessels, and they have to be able to present that to the inspector when need be, and also making sure that the owners are engaging pressure vessel inspectors on the recommended intervals for periodic inspections to have a look at the vessel and just make sure the vessel is intact. Unless the owner themselves, they are fairly confident with the pressure vessel and they say, all right, I'm a competent person, I can do it on my own, I don't need to engage a pressure vessel inspector. But ultimately, if anything happens, whoever has done the inspection is going to be liable for the integrity of that of that particular vessel. But again, inspection is another
I believe
subject
that
for
comes into our
discussion.
next episode.
Let's leave it for then. We've spoken about this in length, and I think let's keep this for the next session. Again, another very interesting world. What's involved in doing the routine inspection, or when we actually need to do inspections on pressure vessels, etc. We covered it all up in the next episode, hopefully. Yeah.
Yes. Thank you, Ali. Thank you
thanks, William.
Thank you very much for attending. Everyone else, thank you very much. Stay tuned for our next episode. Thanks for joining us on this episode of HYDAC Podcast. For an in-depth learning on the subject you've just listened to, enrol on the technical training at HYDAC Australia. For more information, visit our website, hydac.com.au. HYDAC, global presence, local competence.